Probability and statistics is the area of study I find that students either love or hate. There is quite a lot there in the study design. So we have these formulas for sums and linear combinations of random variables. We have the formulas for the sample mean, confidence intervals for the population mean, and finally hypothesis testing. Hypothesis testing is always in the exam 2 extended response. So the exam 1 questions tend to come from the earlier parts of the study design. So we'll have a look at a few past exam 1 questions. Here's one from 2023, and looking at this, I can understand why some people don't like probability and stats, especially if English is not your first language, because there's so much text there. When you could turn back a page, for example, and do this calculus question, which has one word, and we'll come back to that question later. Firstly, let's look at this one from 2022 exam 1. Time taken by a coffee machine to dispense a cup of coffee varies normally with a mean of 10 seconds and a standard deviation of 1.5 seconds. Find the probability that more than 34 seconds is needed to dispense a total of 4 cups of coffee. So actually, the average for this was less than 50%. The reason why is there's a common error that a lot of students are going to make, and that is to use the wrong formula. We want to let x be a normal random variable, mean of 10, variance of 1.5 squared. But the common error would be to let the total time for 4 cups of coffee be 4x. What we should do is let the total be the sum of 4 independent random variables, x1, x2, x3, and x4. If you're a little unsure what is the difference between these two situations, one example that I like to give involves money. So imagine thinking of a number from 1 to 100, and I'm asking you to guess it. If you guess it correctly, I will give you $1 million. Now, would you rather have 10 attempts at this game or one attempt with 10 times the reward? As in, I'll give you $10 million if you guess it correctly and nothing if you don't. So you can think about which one would you prefer. I know which one I would prefer, but bringing it back to the random variable, let's say X is your profit for one game. 99 times out of 100, you're going to get 0. But one time out of 100, you're going to get 10 to the power of 6 or $1 million. If you have one attempt with 10 times the reward, the probabilities are not going to change because you're only having one attempt. All that's going to change is instead of winning $1 million, you could win $10 million. However, if you have 10 attempts at the same game, the probability distribution is going to look very different because you could win nothing, but you could also get 1 correct and win $1 million. You get 2 correct and win $2 million, all the way up to $10 million. This is the option that I would prefer, because there's a more chance that I'm going to walk away with at least $1 million, right? Maybe 2 million or more, but there's going to be a larger chance of me walking away with some amount of money, which $1 million is still pretty good, for me. But what I want to emphasize is these two situations are different, and they're different because they're going to have different variances. So with the 10 times the reward, the 10x situation, this one, and this formula is on our formula sheet, the variance of this one is going to be 10 squared times the original variance. Whereas for the 10 attempt situation, the sum of 10 independent random variable situation, in that case, the variance is going to be the variance of x1 plus the variance of x2 plus etc. So we're going to end up getting 10 times the variance of x. It has a smaller variance, which is the reason why you're more likely to walk away with something. Whereas in the 10x situation, it's really all or nothing. You're either walk away with $10 million or nothing. Okay, so hopefully that little money example will help you to appreciate the difference between a scalar multiple of random variable and the sum of random variables. So let's go back to the coffee question. We had the sum of 4 independent random variables. So the expected value is just 4 times 10 is 40, whereas the variance is going to be the sum of 4, so 4 times 1.5 squared, it works out to be 9. That's the variance, so the standard deviation is the square root, which is 3. Always good to draw up a little diagram, little normal bell curve. We have a normal variable t with a mean of 40. We want to find the probability that more than 34 seconds is taken. Because we don't have a calculator here, we need to use our knowledge of the standard normal. In this case, the probability that t is greater than 34 works out to be exactly the probability that z is greater than -2. And it always has to be pretty much 2 standard deviations, perhaps 1 on exam 1. In fact, I don't think I've ever seen them ask 1. It's always been exactly 2. So what you need to know is between 2 standard deviations either side of the mean, there's roughly 95% probability. So in this case, there's 2.5% that's less than 34. So 97.5 or roughly 98% chance of being greater than 34. So that was a sum of random variables question. Another type of question commonly assessed on exam 1 is a confidence intervals question. And you do have the confidence intervals formula on your formula sheet. So in this example from NHT 2018 exam 1, they specifically told you to use an integer multiple of standard deviations. So for a 95% confidence interval, you're going to use z is equal to 2. Otherwise, it makes the calculation too hard if you have to use 1.96 or something. So in this question, we told the population standard deviation is 21. We're told the confidence interval goes from 44.7 to 51.7. So we need to find the mean and the size of the random sample, n. The mean is easy. It's just the midpoint of the confidence interval. So in this case, it's going to be 48.2. And for the size, we're using 2 times sigma on root n. That must be equal to 51.7 minus the midpoint, 48.2. So that difference is 3.5. We get root n is 12 and n has to be 144. Part B of this question, determine the size of another random sample for which the endpoints of a 95% confidence interval for the population mean would be 1.0 either side of the sample mean. It's pretty much asking the exact same things in part A, with just different numbers. The hardest thing about it, if you know how to do part A, is just working out the square root of 42. Okay, so now let's go back to this question from 2023 exam 1. You can pause the video, read it yourself. It's quite long, but the key is we have 3 random variables, and we're given the mean and standard deviation. We're interested in the total, so the sum of those 3. So again, the mean is just the sum of the 3 means. In this case, that's 40. To get the standard deviation, we first need to get the variance as the sum of the 3 variances. So that's 6 squared plus root 3 squared plus 5 squared. The variance is 64, which means the standard deviation is 8. For part B, we're interested in the waiting time only. And we want to find the probability that for 12 randomly chosen workdays, Josie's average waiting time is between 7:45 and 8 minutes 30. So it's a sample mean question, and we have the formula sigma squared over n for the variance or sigma over root n for the standard deviation. So here, the original waiting time had a mean of 8 and a variance of 3. So the sample mean is also going to have an expected value of 8. The standard deviation is going to be root 3 over root 12 because n was 12, which gives us a half. Now, once we have that, we want to convert that to our standard normal. Again, it doesn't hurt to draw a diagram. We're interested in the probability that x bar is between 7.75, 7 3/4, and 8.5. To convert to the z value, we subtract the mean and divide by the standard deviation. We get the lower bound is -0.5 and the upper bound is 1. So using that sigma over root n formula for the sample mean is another thing that's commonly assessed on exam 1. I would say it's pretty likely that the probability and stats question on your exam 1 is going to be one of those 3 things: a sum of random variables question, a confidence intervals question, or a sample mean question. So make sure you practice those 3 types.